Hello, everybody, and today we'll be talking about week 2 content. We'll be going over the intermediate scripting stuff, getting starting the week off, just ramping you back up on some of those things that we might not have been touched on in Unity, but were covered in Unreal. We're going to take a look at them again in Unity. We'll be digging deeper into state machines. We saw how to set up a simple one at the end of last week. We're going to be digging a bit more into that for this week. You will be having a discussion about breaking games down into their different states and how that could be used. Then down here we have an actual experiment. We'll be going over that a bit on Friday, where we'll provide you with a state machine so you can get accustomed to working with others' code. So even though you didn't write the state machine yourself, you will be using it to add states to it and define what those states do. Then there will be a quick test on how to use the state machine that we've provided, and a couple of questions, things like how do you add a state? What is the proper syntax? Things like that. So to get started, let's take a look at the intermediate scripting tutorials. And there's a few different topics that we'll be covering today. Inheritance, polymorphism. Member hiding is an optional one. It's not very important to designers. That's more of a programmer technique if they purposely want to add a function that's not the same as the parent function, things like that. Overriding, which comes in super handy. Interfaces, and there's extension methods, which again, optional, so don't worry about that one. But namespaces comes up. So we'll be taking a look at how to create our own namespace and things like that. So without that further ado, let's actually, well, let's take a look before we get into covering these topics in Unity. Let's just take a look at some of the other assignments here. There's a test on the intermediate stuff. Then there's this building better state machines, which goes over a bit more in depth on how to make more advanced state machine, what kinds of state machines there are. And then there's this great book, Game Programming Patterns Designs. And this is all hosted online for free at this link. And they have some other designs other than just the state pattern, but it does a really good job of introducing kind of the complex different design patterns that are often used when it comes back. Or sorry, I was just reading the comment. When you're actually going through and trying to come up with software engineering solutions to common problems that almost every software engineering project runs into. This one's geared directly towards game programming, so it'll keep in mind that you have to keep things quick, most efficient, things like that. So I do recommend digging into this book, even outside of this class and outside of this chapter whenever you have a chance. There's some great other things about the book for different patterns. So please make sure to bookmark that one. Then there's the discussion post. As I mentioned, this one will be just going in and out, digging into what games you're currently playing and trying to break them down, trying to analyze it from a state machine mindset of like, what kind of states would this have? What are the exit conditions for those states? Things like that, just to get you in that mindset. There is no right or wrong answer, so don't be afraid to post anything if you're not quite sure what would be considered a state. It is really up to debate, so you're just looking at trying to get into that mindset of what you consider a state really would be. And then there's the provided state machine and the test along with that. We'll talk more on that Friday. So today we will just be covering these topics. So I'm going to jump over to Unity. And what we have here is what we left off with from the last lecture. So I'll just give that a quick play. And that was the state machine for the door. When we walk up to it, no key, it just does partial open. When we collect the key, we can walk up to it and open the actual door. So we're going to just use this as a base project since we have a character moving around to take a look at inheritance. One of the easiest ways to go through inheritance or demonstrate inheritance is with a pickup structure. So right now we just have the one pickup script that is not really even a script. It's just there. It's an empty class so that we can have our character respond when it hits something named pickup or has this script attached. We're going to change that. So I'm going to go over to my player and remove the code for its collision that of when it hits a pickup. So rather than setting the key to true and destroying the other pickup, I'm going to move this actual pickup code itself. Pickups should have their own code. So I'll just comment that out there. And then on the pickup itself, I'm going to make this a base pickup so that other pickups can derive from it and specify just what they need to do when they hit or when the player hits them and stuff. So we have this. We see it is inheriting from mono behavior, so it can be attached to something. I am going to rename it, though, to pickup base so that we know it's a base class. If I want to make sure that it's a base class, I can add an abstract in front of it. What this does is actually prevent it from being applied to any object. Since this is a base pickup, I don't really want it to do pretty much anything. I just want to have an interface that other pickups can define some functionality for. So what we'd want to have for each pickup, well, each pickup usually has some sort of functionality for doing the pickup. And what we're going to do is actually have this script take in, or actually have this function take in a player reference. And we'll just call it pref. I'm going to save this. And right now my name is not matching the class. I can go ahead and fix that real quick. Hop over to Unity, give it a moment, and rename it. Pickup base. And make sure that this gets saved. Could not find pickup because we are looking for pickup base now. All right. So let's create a couple of different pickups here. We have our sphere. I'm going to just get rid of our key for now. And let's add a new pickup to our game. We'll go 3D object, just a sphere. Bring that into our world. Scale it down. Since we have everything working on a pretty small scale here. And I want to make sure that its collision is set as a trigger. Next up, I need a script to attach this. If I try and attach our pickup base, it says you can't because that's abstract. All right. Well, our if we want to create a derived class of this, or a child, inherit everything that has, which right now, not a whole lot, just the do pickup function. We will have pickups destroy themselves after, so we will do the destroy in here. Destroy our game object. Save that. Give that a moment. And we're going to create a new script. Creating a new script, we'll call this one pickup. Let's go with puppies versus mosquitoes. So we'll do puppies first. Pickup for puppies. So this one, I do not want just deriving from mono behavior. I want it to inherit everything pickup base has. So we can change what class its parent is right here. And just say, all right, pickup puppies is now a pickup base. It has all the functionality of pickup base, even though it's empty. So if we close that out, or save that, it looks like an empty script. And our player, when it does detect that it hit a pickup, I want to basically call that pickup's do work or do pickup function. So rather than having two other get components and having to get the component each time, I'm going to do this once and capture it in a local variable. Pickup base, and come on, pickup base P equals our other get component if P is not equal to null, because we could overlap with other things that aren't pickup. We can now check. I forgot a semicolon. Thank you, thank you, error checking. So in here, we can just tell that pickup to do whatever it's got in do pickup. But we see we can't call that function from here. Even though our pickup base has the do pickup, by default, everything in C# is private. So we would have to make this public in order for other classes or other scripts to access it, or be able to call the function, or see any variables that we have, things like that. So our player, now that we have that public, we can call that do pickup straight from there. It does take in a player reference, and since we're currently in our player class, we can just pass this over. This is basically self. Whatever script I'm currently in or whatever class I'm currently in, that's a quick reference to the player or the instance of that player, or whatever class you have. Sorry, keep saying player. All right, we'll save that. Keep in mind, pickup puppies, completely blank script other than inheriting from pickup base. So our sphere, we'll rename that puppies. And we do have it set as trigger. We'll put our pickup puppies script on it. Should see that. And when we play, if we run into it, we don't have anything printing in the console, but it does disappear. So even though we told it empty script and we're actually calling a function from it. Our player is just saying, call whatever your do pickup is. It's, and the pickup type we're getting is just pickup base here. Even though pickup puppies is actually a pickup base. So it's going to just go to the parent and call the parent function. So do pickup was telling it to destroy itself. So now that we've got that, let's make our puppies do something else other than just destroying. So in this case, if we want to change what our parent has for our do pickup, we can use the override keyword. Real good breakdown of blueprints. It's pretty similar. I mean, it's the same concepts on both sides. But we have our override keyword. Override tells us what functions we have access to override, and how we tell it if we want a function to be overridden. That comes in the base class. So in Unity, you do have to specify which functions you want to allow to be overridden. And that's using the virtual keyword. So virtual and override go hand in hand together. The parent has to be marked virtual in order for the child class to override it. So now we can see that do pickup. And we let autofill, I let autofill fill that in. And it comes in with this base do pickup. So basically it's saying, all right, did you want to still do the parent stuff and add some extra functionality before it and stuff? We'll go with that. We'll just add some extra functionality. We'll do a debug.log. And we'll print out playing with puppies. Playing with puppies. Yay! So good times are had when you get the pickup. We'll save that. And we'll go ahead and play. And if we hit this, we see our console does have a message, but I didn't have it marked as on. We got that message to print. If we take a look at debugging this, our player doesn't know anything about our pickup puppies per se. Keem, you have a question?
Yes, I had a quick question. I noticed that you use the double floppy disk to save. Is that any difference from using Control S?
Yes, double floppy is Control Shift S. That's save all. So in case I forgot to hit save from one, it'll make sure to save anything that I've changed.
Okay, okay.
So,
I just
normal.
noticed that you did that, so I was just trying to see what was the key takeaway from using that way to
Yeah,
do it.
just a little bit safer to make sure I did make an edit, jumped over to another script, forgot to save one. It should still save that one.
Gotcha. Thank you.
Certainly. So in our player, I mentioned it doesn't know anything about our pickup puppies. It just knows about this pickup base, and it's saying, pickup base, do your pickup. In fact, even if we're in code and we just right click and go to a definition, it brings us to our pickup base. But it was actually running our pickup puppies, because our puppies are a pickup base overriding the do pickup. So that's where the polymorphism term comes in. If we take a look at this and we attach that, head over to Unity. Yes, I would like to debug. And we play this. We'll go ahead and play. Any minute now. There we go. And we hit the pickup. You see it's detecting the enter. The other thing is a puppies type. We're getting a pickup base type from that. So even though it is pickup puppies, it is also a pickup base. So keep that in mind. Inheritance has is a relationship with the parent. So any child is a parent. That does not mean every pickup base will be puppies. We'll take a look at that in a moment, but let's continue debugging. So we're paused right now at this line. We're checking if it did find or was able to get the component. It was. And then we see it's calling that do pickup. If we go into this pickup or step in here, it'll go to the actual pickup puppies. So even though the type was pickup base, it can treat it as a child. That's the poly part. It can be multiple items at the same time. It is this type, it is this type, and so on down the hierarchy. So that's where we are able to add additional functionality or even straight up override. We'll take a look at that in a moment. But I'll just let this continue, and we see it has a normal behavior of just that base pickup destroying. Let's add another different type of pickup. Let's say pickup puppies. We'll go one more. Pickup mosquitoes. All right, so our pickup mosquitoes, we're gonna make a little bit more annoying because mosquitoes suck. I hate them. So pickup mosquitoes, we don't need a starter update. Nothing needs to be done there. But rather than mono behavior, we'll also say this is a pickup base. And in here, we'll override what happens when we're told to do the pickup. The mosquitoes are annoying and never seem to go away, so what we're gonna do is just comment out that base do pickup so they won't be destroying themselves. Instead, they'll just print a string, debug.log, or let's have this one make use of our actual player ref. So our player is being passed into this do pickup function. So if we want to play here, let's see, we have pref, and from our player we can do anything we want to that specific player instance. We can get a component. Let's go ahead and grab its material or renderer, and we're going to change it to a red color. So get the renderer component, get the material, get the color property, and set it to a color. Let's go red, because I tend to make nice red splotches all over. And they also won't go away. We'll save this. We need something to apply this to. Let's make them a cube. Put that to the right of our player here. A big old swarm of mosquitoes to the right. Make that a trigger. Rename the object mosquitoes. And don't forget to apply the script that we just wrote for it. All right. So we'll give this a play. I'm going to pull open their console. We hit the puppies, and I have a breakpoint still. So I'm going to get rid of the breakpoint so we can just continue playing as normal. And then when we hit our mosquitoes, we've turned red, and our mosquitoes are still sticking around. So mosquitoes never go away as long as you keep walking through them and feeding them. You just get more and more irritated and turn red with anger. So we now have the two different pickups, and the way we're actually calling their functionality, our player's doing our collision check to see, did it hit a pickup? Doesn't know what pickup it hit. It's just saying, do whatever that pickup tells us and pass in a reference to ourselves. So that comes in really handy, allowing a lot of versatility for many people working on whatever pickups they want, whatever functionality they may need, without having to constantly change our player to tell it to do something specific. For example, we have the has key right here. I did make that public, cool. So I could add a new key pickup, because right now we got rid of our old one. Let's go ahead and add, let's do a capsule for that. Whoa, big capsule. It's a weird looking key, but we'll deal with it. 0.25, 0.25, 0.25. All right. We'll add a key here. Add a new key pickup. Pickup key. And each one of our pickups, rather than having to do any error checking or anything like that, or even the destroying themselves part, we can just change the parent, do whatever the base pickup does, and then we'll add some extra stuff to that override. Our override for our key pickup will be talking to our player script, and we'll be specifically talking to the has key bool. We'll set that to true. We'll save that. And give this a moment to run. Oh, it is playing. Oh, and I forgot to turn the collider to a trigger. Darn it. Stupid little pill. Make you a trigger.
Those physics, though, were working nice. Right over it.
Yep. So, and if I would have attached the script, failing all over this key. This is our key. We'll rename it. We'll attach the script. Make sure it is a trigger. There we go. Hit that. All right. We've now got a key. We can walk up to the door, have it open. So you just made the code, well, with this inheritance, we've made the code much more versatile. No changes need to happen in player, any new pickup we add. Each pickup can focus on just what it needs to do. And let's say we wanted some sort of effect for each pickup after they've been picked up, or at least the ones that are calling do pick up for our parent. Let's say we'll have them raise up in the world and then destroy after a couple of seconds. We'll do transform, or maybe even shrink down in the world. Yeah, that might be fun. Local scale times equals 0.5 f, and then we'll destroy it. But I'm not sure if you guys are aware of this, but destroy actually has two overrides or overloads, and it can specify which object to destroy, and then the second one you can even specify a time to delay before destroying. So we'll say they'll stick around for an extra 0.2 seconds after they've scaled down. F. There we go. And without having to add that functionality to all of our pickups, we just did that in our base pickup script, so that now when we hit that, dropped 2 and drop down. Hit that, drops the scale down, and then takes 0.2 of a second to destroy. So any pickups we might have a general effect on, we could just do that in our base pickup, and everything inheriting that functionality now has all of that built in, rather than going an extra mile and having to copy and paste all of that effect code for each individual pickup. Same things can be done for characters and things like that, but pickups is just one of the easiest because it's a simple interaction that we can quickly show different types, whereas characters get a little bit more advanced, and you can break off a lot of different ways of what stats they have, what specific things a player character versus an enemy character might have, and that would take quite a while to demonstrate just this basic inheritance topic. So we've taken a look at inheritance, polymorphism, overriding. Next up, we have interfaces and namespaces. Let's take a look at our namespaces first. So namespaces is something we've been using. I mean, that's standard when you create any script in Unity. It automatically comes with some using certain namespaces up top. But let's say we wanted to write our own. Let's say we wanted all of our pickup stuff encapsulated into a namespace. So similar to how like AI is all encapsulated in UnityEngine.ai. If we wanted to put our pickups all separate in their own namespace, well, you can just create your own namespace by using the keyword namespace, and we'll call it pickups, and then some curly brackets. Anything you wrap up will now exist inside that namespace. So we've got our pickup base in there. Let's do our pickup puppies as well. We see right now it can't find pickup base because it doesn't know about that namespace. But if we put it, oh no, and inside of froze. All right, so I left off real quick. We wrapped this in a namespace. It's all going to be inside here. If we want our pickup puppies to also be in that namespace, we just wrap it in namespace and which namespace you want. We don't even need a using statement here, or using statement up here, because it's in the same namespace. Even though it's across different classes, they all get added to whatever namespace you tell them to. Do the same for our mosquitoes. Namespace pickups. And our key. namespace, pickups. All right. So anything that does want to talk with these pickups, I'm going to just do Control-Shift-B, which is the same as build and build solution right here. So we can see any errors in the editor here. We see pickup base could not be found. Are you missing a using directive? Well, that looks pretty similar to something we've seen before. It doesn't know about pickup base anymore. So let's say we had 1,000 different pickups and didn't want every script in the game finding it. That's a good solution to say only things that need to know about pickups, well, our player needs to know about them, can put them in that namespace. And to access the namespace, it's the same as you access any of the other namespaces. It's just using and the namespace. And then all is good. It's able to find pickup base for us. An alternative, if we're not using it in a lot of places, we're really only using that here and here to find something inside our pickups. If we don't want the using statement, we can explicitly state pickups.pickupBase and pickups.pickupBase so that we no longer need to give our entire script access, just the line of code that we really needed. That can speed up things like compile times, as well as just general searching for items. Your IntelliSense will be much friendlier if you're making good use of namespaces, things like that. You can go overboard with namespaces and end up with hundreds of using statements up top, so kind of watch out what you're kind of grouping together in a namespace. But for the most part, super handy and useful tool to wrap up some pretty common code. So we save that, and we're just going to give this a play test to make sure everything is still working. Hit the mosquitoes. Are they still annoying? Yes. Hit that, and they go away after the 2 seconds, and puppies disappeared too. But we did get to play with them for a little bit. All right. So, raised hand, yes.
How does the namespace look in the inspector now?
In the inspector?
Yeah.
The inspector doesn't change for namespaces.
Okay, I thought that it would like add something at the top, like a label or something.
Nope. The inspector has no idea about namespaces. That's just purely the code itself.
Cute.
Yep. All right. So before we get into interfaces, I want to take a quick 10-minute break, and then we'll start back up at 2 p.m. All right. So we had a request to go over the optional stuff as well. Let's cover those real quick first. So for member hiding, basically that's a dirty way of overloading. So for example, our pickup mosquitoes, or overriding, I mean, rather than overriding this do pickup method, if we use the new keyword, we're doing what is called hiding our parents method. So for example, if we just do it like that with no virtual, it'll immediately tell us that it hides inherited member pickup base to pickup. To make it override the current, And of course, it goes off screen. Add the override keyword. Otherwise, add the new keyword so it's not just hiding the member automatically. If we did want this to be a completely new function so that this gets called instead, whereas we don't want any of the base functionality, we could just have that new keyword there, and it'll still react the same in game because we already commented out the base. But one disadvantage new keyword does is it does look like it still has access to base. I'm curious. Oh, I have to pass in the pref. So, all right, that was just a quick test. We'll save that out. But this is, for example, if you wanted to just quickly override without the default base added stuff. Should still react the same, where it only runs the child class and not the parent. So we should see that not get destroyed. Oh, we do see it get destroyed. So this is just adding on new functionality. And our character did not actually turn red when it touches the mosquitoes anymore. So even though our mosquitoes is telling it to do that, this is actually a new function separate from that parent hierarchy. So our player would have to actually cast to the specific type. We could do a cast here. Let's just cast this P, which is of type pick up base here. We'll cast it to pick up mosquitoes. And I forgot I did the pickups namespace, so we'll have to add that. And that's actually looking to see if this type is actually a pickup mosquitoes, even though it is a base before it's calling now. So now when it hits, it's just going to call that one type versus going through that parent hierarchy. It's completely ignoring that now because we've done the new keyword. We're hiding that previous member of base.do pickup. And we will have a problem hitting our other pickups. We'll get no reference or cast not valid because not all our pickups are mosquito types. So that does allow you to change certain functionality if you have interesting hierarchy interface. But as I mentioned, that is optional and you typically wouldn't have to worry about that as a designer since you can work with just explicit types directly. So rather than doing new, we'll keep that the override so that it is in the parent hierarchy and can do this instead of the parent. And we still have that base functionality we could add in if we really want it to do the parent. All right. So yeah, member hiding is kind of boring. Extension methods. That's actually a more advanced topic. So extension methods allow you to write functions for some other classes and things like that. Let's say we wanted a general function to reset the scale of something. So our current scale of our player is 0.5, 0.25, and 0.5. Let's have a reset added so it can scale it up to just 1 all across the board. For that, I need to create an extension class or something to write this function in. I'm going to just throw it in our player script. We don't necessarily need to have classes and separate scripts. One thing about extension methods, they do have to be static. So static means there's only one instance shared across the entire class itself. The class doesn't have instances itself. There's only a single one. So static, let's call this, oh, bugger. What am I thinking of? Reset extension. This is a class. And we'll change the functionality of, we also need this to be a public function. Do a public static function, so it can be called outside of this class with just one instance. And we'll be calling this reset our scale. And we'll be taking in transform. We'll call it T. I know I'm forgetting something here. I think I'm forgetting to pass this in. And it doesn't like that. It's been a while since I've written a extension method. Excuse me one moment. This lowercase t, darn it, so close. This lowercase t, we also need some sort of return type. Void. So what this is doing, it'll inherently use the transform that's passed in, essentially. We'll have some, when you're calling this function, we'll take a look at that and see some interesting behavior. As I mentioned, we're just going to reset our scale. And we'll just do a new vector 3. Oh, I can't do new vector. I want just vector 3. 1, 1, 1, 1. Yes. So it's just going to set the local scale to all ones. Then in our player, let's say we had some sort of button press to do this. If input get key down, key code, and let's set this to our T key. When we press this, let's try and have our player actually call this reset scale. So let's see, reset scale. Nothing's going to show up there. But from our transform, we actually have that extension method showing up for resetting our scale. Now that's not something built into Unity, that is something we just wrote. As far as parameters, we see it doesn't take any in. Well, that's a little funky because, and we'll do split screen view for this. I'm going to just drag this down so we can see the code trying to use it. And on the top one, we'll scroll up to where it's defined. This transform T means if we are working with a transform type and we're calling reset scale on it, it's already passing this transform into that. So technically this is this dot transform. Oh, cutting out, no. So technically this transform is this dot transform. That's where the this comes from. It's just saying anytime you call reset scale, on a transform type, it's going to inherently pass that in to the extension method. Go back to normal view.